So everybody has a, a white powder, which is this is unknown. The thing that's unknown about it is we know for sure there's sulfate in here, and the sulfate's in the solid state, so it's in some kind of crystal lattice with some cation. And since this sulfate it dissolves in water alone, that tells us some information. Because if it completely dissolves, then we can't have certain ions in significant quantities. What ions are not present in significant quantities? That means if it dissolves, then we cannot have. Well, what are the insoluble sulfates? Someone have those memorized for me? Yeah, barium, calcium, yeah, strontium. Do you have these memorized, like automatic? Not yet? Getting there? Repetition, right? Repetition is it. There's no, silver, lead, mercury, calcium, strontium, and barium in significant quantities. What I mean by significant is if we have trace amounts, then yeah, trace amounts might dissolve, but no significant. And so one thing is, this test tells us that, okay, there's none of these cations, but any other cation is possible. It's a lot of possible. So we've eliminated these. And so there's other stuff in here, plus other. I mean, we can't just have sulfate, pure sulfate. There's got to be cations. And now what we're going to do is we're going to add excess barium chloride. The excess barium chloride is going to precipitate out all our all our sulfate is barium sulfate. But barium ions precipitate with other ions as well. So we know barium ions like sulfate ions. And we form barium sulfate. But what other anions like barium? What other anions like barium? This is a chemical properties question. Bromide, no. Barium bromide is soluble. Barium chloride is soluble. Barium iodide is soluble. Those aren't going to precipitate. They're just going to stay as ions in solution. So what other ions like barium? Hydroxides, yeah. Although, wait, hydroxides, let's think about this. Hydroxides are all insoluble except for group 1, ammonium. What else? You guys have to have these down. I mean, even in Chem 4, a lot of Chem 4, when I normally teach it, they have to have it memorized by the end. You'll have to have it memorized by the end of the semester, for sure. If you've never had to do it. The people who've had to memorize in Chem 4 will have an easier time of it. But by Chem 1A, you guys should be pretty comfortable with the solubility rules. For sure, by Chem 1B, it's got to be more automatic. Okay. And so hydroxides are all insoluble except for group 1, ammonium, and calcium, strontium, barium. So unfortunately, hydroxide is not one of them. But there's others. Carbonate. And so if there's carbonate present in our unknown, could there be carbonate? Yeah. There could be carbonate present in our unknown, as long as we don't have these. There could be, we don't know what the cation is. So there could be carbonate, and that would form barium carbonate. So, what else might be present?
Nitric.
Chromate, yeah. Although, you know, chromate is yellow. You know, maybe you have small amounts. And barium chromate is, guess what color? Yellow. So we might be able to eliminate this one based on color alone, because there's certain ions that are going to be colored, like permanganate. Do you think you have any permanganate in there? It's purple. No. It's a white unknown. So color tells us something. Solubility tells us something as well. But yeah, chromate's a possibility. What else? Sulfide? Sulfides are all insoluble except for group 1, ammonium, and group 2. So sulfide would be soluble. Come on, tell me the most insoluble anions. Carbonate's one of them. What else? Phosphate. All these can form. All these can form as our precipitate. And so we don't know if our precipitate's pure barium sulfate or not. Which brings us to why we add the HCl. Do you know why we add the HCl? We add the HCl because of this. The HCl's purpose is to eliminate all the other precipitates except for barium sulfate. The reason is you know, when I look at barium sulfate solid plus HCl, what I would end up with is getting barium chloride plus H2SO4. Barium chloride soluble, and so we might be going from stronger acid to weaker acid. Are we going from stronger acid to weaker acid? No, we're going from strong acid to strong acid, which means no reaction. And so there's no reaction, there's no driving force here because of the leveling effect. Right? Leveling effect. Whereas, let's say if I form the carbonate, if I form barium carbonate, I would form barium chloride again, but in this case, I would have driving force. Because here, I would be going from, I'd form carbonic acid. I would be going from HCl to CO2, which is a weaker acid, so carbonic acid. And so the driving force is here. We're going from stronger acid, HCl, to weaker acid, which is a combination of CO2 and water. Weaker acid. All we need is one driving force. Stronger acid to weaker acid. And so the HCl, if there's any carbonate here, the HCl will attack it, prevent formation of barium carbonate. The same thing with barium chromate. You know, although since this is yellow, do we have any yellow precipitate in there? I'll just kind of eliminate this because of the color. At least we wouldn't have it in significant quantity. But even if we did have it in significant quantity, we would form chromic acid. And so again, we'd go from stronger acid to weaker acid, H2CrO4. Barium phosphate, what would we form here? Can you figure it out? And see if there's a driving force? Plus HCl. What would he form in that? This is a metathesis reaction, double replacement reaction. So can you go ahead and figure out the products of that?